Cool. So I wanted to kind of expand on the video I did yesterday and kind of keep this one a bit quicker and a bit more concrete in terms of building agents and building workflows with agents. So this is actually going to be all about workflows and nothing about AI specifically, because I think this is a building block in terms of how you can use AI to kind of execute workflows. But what does it mean to build a workflow? And thinking of your work as workflows and nodes and steps and things like that. So what I want to kind of convey is a concept called state, and not the state you live in, of course, but like the state of a workflow, meaning like what is the environment almost, right? Because if you think about our workflows, a lot of times, let's just take a like a credit card accrual entry. Just I'm picking things out of the top of my hat. But basically, you might have a step where you go pull a report, you put that report in Excel, and then you go start filtering down to get to the information that you need to make your journal entry, right? And so you can think of those as different steps. And in the context of state, there might be intermediate results that you need from those different steps that are kind of part of the overall environment or setting of your entry. So kind of a weird concept, but bear with me. I think it'll make sense as we go through the live demo. But what I did want to kind of lead with is this, whiteboard drawing here of, you might have a workflow state, like I said, and we're going to have nodes, which are basically blocks of work, and they're going to be in code, but it doesn't really have to be in code, but just as a concept, blocks of work that are going to make changes to the state. So these group of nodes represent an overall workflow, a graph, and the node's job is to just make updates to the state of that graph. And so, we have 3 different nodes here, step 1, step 2, step 3. And basically what I'm trying to convey is that these nodes, their sole job is to, do some kind of action in step 1 and return the result of that back to the state and save it in the state. Same thing for step 2, same thing for step 3. And then at the end of the day, what you have is a final result, which is like a fully updated state that has all the values that you set out to go get. Now, that's very theoretical, so you might be saying, what are you talking about? Well, let's kind of break it down into a real application with Excel and fake transaction data and kind of see how it works. So what we have here is a very basic agent.py file. This really, again, doesn't have any AI involved, at least in this demo. But I'm going to kind of walk through the code high level. Again, you don't have to be a coder or a programmer to necessarily understand this, or I don't need you to understand it fully first time seeing it, but I think the concept of state and what that means is important. I think we are already familiar with it. We just think about it differently if you haven't seen this before. So, I'm going to go ahead and import the certain libraries that we need for this. So Langgraph, I think, is what manages all the different, the graphs and the nodes. So I'm going to import that. I'm also going to import a typed dict, which is a typed dictionary that's going to be defined as our state. More on that later. And then pandas to help manipulate Excel and work within Excel in Python. You may be familiar with that one already. And then pprint, which is just pretty print, just to make things look nicer when we print it out on the screen here. So that's all I'm importing. It's pretty relatively small for like a Python program as far as that is concerned. So let's go ahead and dive into the state. So what I'm defining here is this is my workflow, and I have, looks like 6 fields that I want to save as part of this state, because these are fields that I think are important to the overall kind of environment or setting of this workflow. So I have file paths. This is a file that what the CSV is that's going to be reading in this process. And then the actual content of the CSV, we're going to save that down. It's going to be a list of dictionaries. You'll see what that looks like when we print it out, if that's not familiar to you right now. And then the total number of rows, because I think it's good to have a certain kind of like metadata when you start using these kinds of automation. You might want to check, okay, does the number of rows I have match with my human eyes, what I can kind of check and see, because we'll always want to have, at least in the short term, some element of human review, right? So I'm going to have it save the total number of rows. I'm going to have it save the sum of the amount, all the total transactions, sum that whole column. And then I'm going to actually try and filter for entertainment spend in the data set that we have. and then I'm going to have a journal entry path. This is where the file is going to be saved. So let's go ahead and take a look at this. Cool, so now we're going to talk about the nodes. So we just have a couple nodes here. The first node is going to be, we're going to load the CSV file. So in this function call, we're going to take in the state object. That is this workflow state. That's exactly what we just defined a second ago. And it's going to return an update to that workflow state. Okay, so that's what this little line here means. And below that, we have a little description about what is going on in this node. It's going to load the CSV file into the state from the path that we tell it to. So our file path is state.filepath, and then we're going to read the CSV file using pandas. That's the pd.readCSV. And then from there, we're going to convert that into a list of individual dictionary rows. So you see what that looks like when it gets printed out. But then what we're going to do is we're returning this key value pair. So we're returning a updated data content list for the key data content. So you might be saying, well, what does that mean? If I scroll back up, I have this data content key in my dictionary. And so what we are telling in this node is we're saying, hey, for that data content key, populate it with the data content list. That's what this is doing. So again, the nodes should be very modular, and they should be only kind of updating a couple of things in the state, and they should only update the state. It shouldn't be doing too much all at once. So that's kind of what's going on there. So that's the first one. And then the second node that we have is calculate file metrics. So this one, again, takes in the state, returns an update to the state. That's going to be, you're going to see that be consistent for a while. So our total number of rows is going to be the length of our data set minus 1, because we have a header row, right? And then the sum of the amount is going to be the sum of the column amount for each row in our data content object that's in the state. So it's going to go through each row. That's a list comprehension if you're familiar with that in Python. It's going to go through each row and sum the amount key for that dictionary and aggregate all that, okay? And then when we want to filter for entertainment, what we're going to do is we're going to do that same kind of list comprehension, but we are going to filter for entertainment as a category, okay? And so from here, we're going to return the updated state. In this case, we're going to return more than one update, but it is just an update to the overall state. So we're returning total number of rows, sum amount, and entertainment amount, okay? And then from there, our last node in this is we're going to create a journal entry. So again, takes in our state, returns update to the state. You get that by now. Our output folder is just going to be hard-coded data/output. And what we want to do is we want to get the entertainment spend. This is going to be a journal entry for like an expense accrual, okay? And so we're going to get the number from our state. So you can see state, brackets, entertainment spend. That's the dictionary key that's going to have the value of the entertainment spend that we got in the last node, right? So then we're going to have a simple header row, journal header, date, description, amount, and account. Pretty basic, just for proof of concept. And then debit expense line is going to be today's date, expense, entertainment expense posting, entertainment spend, and then our GL account is going to be entertainment expense. And then on the credit side, same thing, but it's going to be a negative entertainment spend, and we're going to call it expense accrual. So that's that. And then what we're going to do is, in order to get this to be a CSV file, we're going to convert it into a data frame, which is just basically like an Excel file, for lack of a better term, using that pandas library again. And pandas has a great feature that is to CSV. So it just kind of go ahead and outputs that data frame that you have to a CSV file with the file path that you give it, okay? So in our output right now, there's a file there. I'm gonna go ahead and delete this. That way we can see it kind of populate. And then we'll go ahead and run this in a second. So that's our nodes, and that's kind of how it works, kind of top to bottom. We'll get into the graph here in a second, but I did want to show the data real quickly, and I'll zoom in a bit. That way it's a little bit larger on your screen to see. So here is our fake data. I just actually asked ChatGPT to make this data. So someone is paying top dollar for Netflix. I don't know what's going on there, but you can see it has merchant, category, amount, date, and then transaction reference number or something like that. So that's what this is. It's got a pretty good amount of lines. I think it's 151 lines. And so that's what the data looks like that our graph is going to ingest. Okay. Now, how does this all work? So great, I have the steps, I have the nodes. How does it all actually work? How do we run this? Well, what we have to do first, when we have a graph, which again is that kind of series or that sequence of work, we need to make it into a graph with Langgraph. So this section down here is we're going to turn it into a graph with graph equals state graph, and we're going to put in that workflow state that we defined up above, and then we're going to add the nodes. So graph.addNode, load CSV, calculate file metrics, create journal entry. So those are all the nodes that we just talked about above. And then we're going to add edges. So edges is basically, it tells the graph on what steps to go do next. So of course, add edge start, we're telling the graph that you're going to start here and you're going to start with load CSV. And then from load CSV, you're going to go to calculate file metrics. And then from calculate file metrics, you're going to go to create journal entry. And then to create journal entry, you're going to go to end. Okay. So that's what those are doing there. And then in order to make this a runnable graph that we can execute, we need to turn it into a app, or we need to compile it, this graph. So that's what this last line here and this little section is doing, is turning it into a runnable. And the concept of a runnable is a bit foreign at first, but that is kind of what underpins a lot of OpenAI and Google Gemini agent development kits, is this concept of like a runnable graph or runnable agent. So we're turning this graph that we defined with all these different nodes, all these different edges in this state, and we're going to turn it into something that we can run and execute. Okay, cool. So we talked through our Python file here, and again, it is a bit of code, but I think the first time you see anything, it looks new, right? So try to stay with it. I promise you, it's not as foreign as it might feel. But yes, we have our state. We define the nodes, and we define the graph. And then we're going to compile that graph. And now we have an application that we can run and we can invoke. And so we're going to invoke it with an initial state. And we're going to print out that initial state with breakpoints. So you're going to see the program kind of pause. And I did that on purpose so that way we could look at the values. If I didn't have that, it would just run all the way through. And you wouldn't really get to see kind of as it works through it as well. So that's what I have here. And then we're also going to print out the graph of a visual of what it looks like here. So I'm going to go ahead and delete this. I'm going to delete the file here. And that way when we run it, you'll see it kind of all populate as we finish up the execution of that app. So I'm going to go ahead and hit agent. So there's our initial state. It's blank. That's what we expected. I'm going to go ahead and hit C. There's an updated initial state because we gave it that file path we want the graph to read. And then here we start the for loop. So the first one is nothing. There's the file path that's going to start going through and updating the state as it streams through the different steps in the graph. So there's the next step. We have the data in there now, and now the next step is going to populate those kind of totals, like the count of rows and stuff like that. So there's the row count, there's the sum of the amount, there's the entertainment spend, and then if I do this one, it should be the journal entry path, I think. So there it is. So journal entry path, data, output, journal entry CSV. And I think if you were looking, you probably saw that pop up over here, and we saw this graph PNG pop up over here. Let's go ahead and take a look at the graph PNG first, because I think it's helpful I'm a visual person, so that's just what I like. And I have it up right here. So you can see here, this is our flow, right? This is the way our nodes kind of operate. So we have the start, it goes to load CSV, it calculates the file metrics, it creates the journal entry, and then it finishes. Again, this is no AI, and I think that's honestly a cool thing, because so much of our work doesn't need AI, and it might add unnecessary complexity to include AI when it's not needed. So you could, just like I did, download Python on your machine, install these libraries, and run this, and then you no longer have to manually do this in Excel. You can just go in here and execute that code, right? Now it is complicated, and there is a skill curve to programming with Python and stuff like that, but it's not insurmountable. I'm a traditionally educated accountant and CPA. Started off at Big Four. I never worked in any kind of technical job other than just accounting, right? So you could definitely do it. I think it just you need to have your own why. And for me, I was spending so much time in manual Excel files that it was painful. And I was like, there has to be a better way. And I think there's a lot of accountants that have that same experience and get kind of push down this path. So in any case, really cool. No AI, just simple workflow, deterministic steps. But let's go ahead and open up the Excel file. Let me go ahead and open that up here, journal entry, and there we go. There's our simple journal entry. Pretty cool, huh? So, there's our headers, there's our GL accounts, the amount, and so on. So let's go ahead and just do a little spot check. I'm doing this live if that expense amount is right. So 3,986. We go up here. And we go and do entertainment. And let's go ahead and sum this up. 3,986. Pretty cool. And looks like, again, it's, I don't know how ChatGPT got these numbers, but there are some expensive Netflix subscriptions and Spotify subscriptions. Let's go ahead and check the total amount, because I think that was one that we had as well. So the total amount is 37,915. So I'm going to go back to the file, and down here we can see 37,915, 12 cents. And then here it looks like there is 151 rows, but if it's just data, it's 150. And I think I had an error there because I had 149. I think when in my code, and I'm gonna leave this in the video because it's never gonna be perfect the first time, so I'm gonna keep this in there and show everyone that building something is you iterate, right? So it looks like I assumed that the content would have the header row, but if you think about our data content object, let's see if I can go to the very top of this without it going into or going off the screen here. If you think about our data content object, it's just the data, because we aren't grabbing the headers as its own row. So it makes sense that I wouldn't need to subtract 1, because that's just not how the program is working. So there you go, lesson learned, and it's always good to check your results, right? Even if you have a computer doing it. So, but yeah, that's how that works. And in my future demonstration, I'll kind of start layering in more complex workflows, but I did want to kind of share this concept with you around nodes and also around state, because I think it's a really cool way to think about our work, and that ties into how we can have AI help us, augment these workflows with this way. And I'll kind of tee that up next for a future video. So thanks everyone. Let me know what you think, and yeah, happy for feedback.